Okay, so if we have a force and it's acting on an object, it'll cause that object to accelerate. The net force will cause it to accelerate. And if that net force is acting on an object through a distance, the product of that force and distance gives us a change in kinetic energy. So this work over here causes a change in energy. So work is equal to the force that's parallel to the distance times the distance. So let's look at an object. It's on the planet Earth. So I'll put the Earth down here. And so this object is mass m, has a gravitational force acting on it straight down. And if we drop the object, the box, the force due to the gravitational field is a force that does work. It's going to be acting on it over a distance. Therefore, the force due to gravity times the distance the object moves is the work done by this gravitational force, the Earth pulling on it. So if we call this the d, the distance between the initial position and the final position, then d is delta y, which would be y minus y naught. So that means that the gravitational force, which is pointing down, negative, times y minus y naught would be the work done by this gravitational force. So if I substitute mg, I get negative mg times y minus y naught, and I can leave the negative sign out front and have mgy minus mgy naught. And so this component here is a force, mg, times a distance, m. And when you have a force times a distance, you get work. And work is measured in joules, which is also a unit for energy. So work is measured in joules, and energy is measured in joules. So this must be an energy that the object had stored because it was at that place. So this is our gravitational energy, or energy stored in the gravitational field. So that means the work done by the gravitational force would be negative Eg minus Eg naught, which is the work done by the gravitational force, negative delta for change, Eg. And that is our gravitational energy. So think about it, as the Earth is pulling the object down, it's doing positive work, but when an object is pulled down, it's going to a lower energy state. So this work done by the gravitational force is causing a change in the gravitational energy. So this is the energy stored, I don't like to use the word potential, stored in the position of the mass. So when a mass is at a higher place, there's more energy. When an object is a lower place, has less energy. That's why we like to slide down tall slides.